let's talk about continuity. And we're going to talk about continuity through its opposite, discontinuity. So when I say, let's talk about a continuous function. When you see the word continuous, what do you think about? What do you think about a graph when you see the word continuous? It keeps going on forever, right? That's what you think about when you see continuous? To an extent, that's what we're going to talk about. The graph will keep going on forever. But more importantly, when we think of the word continuous, when we talk about continuous now, continuous just means that the function has no gaps, holes, or breaks. So when we talk about a continuous function, we're talking about a function with no gaps, holes, or breaks. And the easiest way to do this is, because when we talk about a function like that, the easiest way to do this, there's so many functions that don't have gaps, holes, or breaks. So the easiest way to do it is to talk about functions that do have gaps, holes, or breaks. And we call those types of functions discontinuous functions. So we're going to talk about discontinuity today. And the good thing about discontinuity is it's easy to identify because it only occurs in two functions for us. We're only looking at two functions that are going to be discontinuous. So we're going to look at, there's three types of discontinuity, but it only occurs in two functions. So we're going to look at this first. We're going to look at discontinuity that occurs like this. You have a graph that looks like this. You have a graph made up of all these pieces. And the continuity is jumping from piece to piece. What kind of graph is this? What would you call the type of graph that's made up of pieces? That's a hint, by the way. What kind of graphs are made up of pieces? Say it again. A piecewise function, right? Piecewise function. So when we talk about a piecewise function, a piecewise function can have discontinuity. And if it has discontinuity, it's what we call jump discontinuity. Because you're jumping from piece to piece on this function. You can also get a discontinuity that looks like this now. Graph is going along and all of a sudden you get a break in the graph. Or this right here. What does that look like in the middle of the graph? What does it look like in the middle of the graph? A hole. So if you get a hole in your graph, thanks. You get a hole in the graph, you get what's called removable discontinuity. And then the last type of graph you can have is going to be something that looks like this. Where you get these imaginary lines appearing in your graph. And these imaginary lines are lines that you can approach but never touch. What do you call those? Lines that you approach but never touch. Anybody know? You know. Say it again. I heard it. What are these lines called? These imaginary lines that you approach but never touch. You approach it but never touch. You approach it but never touch it. I'm hearing it. I heard it. Starts with an A. Say it again. No. Keep going though. But it sounds almost like it. Part of it did at least. Good. Asymptotes. So when you have these asymptotes, asymptotes are lines that it approach but never touch, you get what's called infinite discontinuity. Alright, so you have three types of discontinuity. They are jump, removable, and infinite discontinuity. They only occur in two types of functions though, which is nice. Discontinuity will only occur in the functions we talk about, at least. Discontinuity only occurs in a piecewise function, or it occurs in a rational function. What is a rational function again? What is a rational function? Rational function. What is it? Talked about it. Rational function. What is it? Okay, a ratio, and a ratio is a what? A fraction. So if a function looks like a piecewise function or a fraction, it could possibly have this discontinuity. Do you understand that? And we're going to check for the discontinuity. So here's how we're going to check. Here's a question that it's going to ask. I want to know if f of x is continuous. At the given value of x. So I want to know if f of x is continuous at the given value of x. That's what I want to know. So here's an example. Take this function f of x is equal to 5x plus 4 when x is greater than 2, and 2 minus x when x is less than or equal to 2. And I want to know, is this function continuous at x equals 2? If I were to say to evaluate this function, which one would you evaluate on, the first or the second? Why the second function? Because it's equal to it. Does everybody understand that? Here's what we're checking for continuity and discontinuity to begin with. We have two different functions, right? And the endpoint of each function is what number? Or the bound of each function is 2. You understand that? Well, if the function is continuous, then here's what should happen. When I plug in 2 to this function, it should equal the same thing as when I plug in 2 into this function. So that means the function will keep on going. You understand that? But if I get different values, what does that mean? The function is actually going to be discontinuous because you're now trying to jump to a different value. I got that? You're jumping to a different value. So here's how this is different first. Normally you would just take this 2 right here and plug it into this function and evaluate, right? What you're going to do here is take 2. Plug it into both functions. So I'm evaluating f of 2 first. I'm evaluating the top function first. So what's 2 into the first function? 14. It's 5 times 2 is 10. 10 plus 4 is 14. If I evaluate the second function, f of 2 is equal to what? 0. 2 minus 2 is 0. Now, what that tells me is this then. Is this function continuous? Did I get the exact same value for each one of these functions? So that means it's going to have to jump when I get to a certain point. You understand that? So this means that my answer is the function continuous at x equals 2? The answer will be no. What kind of discontinuity do I have here? Jump. So what you're checking for this type of discontinuity, when you have jump discontinuity, the first thing you're going to do is you're going to evaluate the function. You're going to evaluate on all pieces of the function. So you evaluate all pieces. The second thing you do is you want to know if they're the same value, that means it's what? Continuous. If they are different values, what does that mean? It's discontinuous. It means you have jump discontinuity, right? So I want to know about this one. Here's another example. F of x is equal to 1 over x when x is less than 0. And it's x when x is greater than or equal to 0. I want to know about the point. I want to know about the value x equals 0. Is it continuous or is it discontinuous at that particular value? Well, what do we do first? Plug in 0 to both the functions, right? So f of 0 on the first function is just 1 over 0. What is that equal to? What's 1 over 0 equal to? Try that again. 1 over 0. It's undefined. What about f of 0 on the second function? That's equal to what? 0. Is undefined and 0 the same values? Are they the same values? No. So what does this tell me? I have what kind of discontinuity? Jump again. Now here's what I want you to understand. When you have a piecewise function can be either continuous or discontinuous. You understand that? It's continuous if they're the same, it's discontinuous if they're different. But the only type of discontinuity you can have is going to be jump discontinuity, alright? The only type of discontinuity you can have for a piecewise is jump discontinuity. So, that leaves us with two other types of discontinuity which are removable and infinite. Let's talk about those next, alright? You get removable or infinite discontinuity when you have a rational function. And here's an example. I want to look at the function f of x is equal to x plus 3 over x squared minus 9. And I want to evaluate this function when x is equal to 3 or negative 3. Let's talk about why the discontinuity exists first, if there is a discontinuity. Before we even do anything, if we try to plug in 3 into this equation, what do we get? Well, what's 3 plus 3 at the top? What's 3 squared? What's 9 minus 9? So you get 6 over 0, which means the function is what? Undefined, right? Do you understand that? So at 3, you're going to have some kind of discontinuity. At negative 3, plug it in. What's negative 3 plus 3? What's negative 3 squared? What kind of 9? It's negative 3 squared. Positive 9. 9 minus 9 is what again? So at negative 3, you're also going to get 0 over 0, which is an undefined value, right? So both these values are producing undefined values, which are discontinuities. You understand that? So we need to see what kind of discontinuity is. Here's how you do that. Your first step is to simplify this by factoring, if possible. Can we simplify this by factoring? Yes. The bottom factor is how? Thank you. It says x plus 3 divided by x plus 3, x minus 3. Now, what ends up happening here? The x plus 3's can cancel out, right? What are you left with when you cancel out that x plus 3? Try it again. 1 over x minus 3. Why is it not 0 at the top? Good. If you left 0 at the top, that would make the whole thing what? 0, right? So you have to have a number, so we put 1 over x minus 3. Now here's what happens. Once we're at this part again, we're going to evaluate it again with these same numbers. If I evaluate this function at f of 3, so I'm going to evaluate the simplified part at f of 3. Plug in 3. That's 1 over, which means it's what? Undefined again. If you get an undefined value from a fraction like this, you're going to get what's called infinite discontinuity. That means you have an asymptote at that point x equals 3. That means an asymptote exists there. If I evaluate f of negative 3, what do I get there? 1 over what? Negative 6. Right? If you get a value, this is called removable discontinuity. And this particular value is going to be a whole. And what that means is that the whole occurs at -3, -1/6. That means in your graph at this particular point, you would have an open hole there. You understand that? But if we take the hole out, if we remove the hole, the function is now continuous again. As opposed to this right here, you can't remove it, so the function is always going to have a big gap at this part. But it works like this. If you get a undefined value when you do this, it's going to be what? Infinite discontinuity, all right? If you get a number when you do this, it's going to be removable discontinuity. So here's another example. F of x is equal to x squared plus 7x plus 12 over x plus 4. I want to know about the value x equals -4. Why do I care about the value -4? Well, when I plug in -4 into this bottom part, what happens to it? It becomes 0, right? Plug in -4 to the bottom part, it becomes what? 0. Everybody understand that? Something an undefined value. So let's see if we can remove it or if it's infinite. You understand that? That's what you're checking for now. How do I see if I can remove it or if it's infinite? What do I need to do? Factor it out. So we'll factor it. So we get f of x. Top factor is how? Thank you. X plus 3, x plus 4, divided by x plus 4, right? Anything cancels? So I'm left with this is equal to just what? X plus 3. Now, I go back again and evaluated f -4. What is f -4 equal to? -4 plus 3 is -1. So I get a point -4, -1, which is also going to be that's the hole, right? So if I have a hole, what does that make this? Removable. If I get an undefined value, it makes it infinite. I understand that. So, 3 types of discontinuity. They are jump, what else? Whole or removable, and infinite. Here's a checklist to help you remember what they are. Here's how you're going to do all these problems. Here's a checklist for discontinuity. The first question you should ask yourself is, do I have a piecewise function or a rational function? Because if it's not a piecewise or rational function, the function is going to be continuous. You understand that? If you look at the blue sheet real quick, look at your homework real quick. Look at number 1. Number 1 asks you about the square root of x plus 5 or x plus 8. Which one is it? X plus 5. Is it going to be continuous at x equals 8? Yes or no? Is it a piecewise? Is that a piecewise function? Is that a piecewise function? Is it a rational function? No. No. Is it a piecewise or a fraction? No. So what should the answer automatically be? It's continuous. Number 1 should automatically be continuous without even doing any work. Because it's neither one of these types of problems. I understand that. You only have to check for discontinuity when you have a piecewise or a rational function. When you have a piecewise function, here's what you're going to do. The first thing you should do is evaluate. You evaluate on all pieces. After you evaluate, if you get the same number, what does that tell you? It's going to be what? Continuous. If you get different numbers, what does that tell you? It means you have what kind of discontinuity? Jump. for a rational function, when you have a rational function, what do you do first? What was the first thing we did for a rational function? We tried to factor it, right? So you're going to try to simplify by factoring. Bless you. You're going to simplify by factoring. After you simplify by factoring, you then try to evaluate, right? When you evaluate it, if you get a undefined value, what does that tell you? An undefined value means you get infinite discontinuity. If you get any kind of value that tells you have a what? It means you have a hole and you're going to get removable discontinuity. Are there any questions though? Do you understand what we're doing here? Discontinuity is simply checking to see if you have a piecewise or a rational function, alright? If you have either one of those functions, evaluate and then use these rules to tell what to do, alright? You have homework due tomorrow, the red and the blue sheet. You have a quiz tomorrow, if I understand that.
Yes, sir.
Go ahead and work on the homework then, please.